begin a new section. This particular section is no longer on exponential functions, but it's on a type of function that's related to the exponential function called logarithmic functions. Now in the last chapter we were looking at different positive numbers not equal to 1 raised to powers. For example, we know that 2 to the second power is equal to 4 and 2 to the third power is equal to 8. And we know that the exponent can be any real number because logarithmic or exponential functions, the domain is all real. So I'm wondering, in between 4 and 8, is there a number that I can raise 2 to and get 6? Now you would think it would be between 2 and 3, but how do we find that number? What is that number? Well, we're used to raising a number to a power and then figuring out what it equals. Now I know what it equals and I'm trying to figure out what power it is. It's as if I interchanged my variables, which means that I'm no longer working it as an exponential, but the inverse of an exponential, which is the logarithmic function. Definition here. A logarithmic function, let x and b are positive real numbers such that b cannot equal to 1. So they're positive but not equal to 1. And so is x. X is positive. Then y equals the log base b. This is the abbreviation for logarithm. The log base b of x is called the logarithmic function base b, where y equals log base b of x is equivalent to, now notice here, what is it equivalent to? It's equivalent to b to the y equals x. Now think about that. A little bit ago, in the previous section, we started with functions that looked more like this. So if I was to replace the f of x with y, interchange the variable, see what I get? I get right to here, which according to this definition is equal to this, which means that if this is f of x, this function here is its inverse. So these are, the exponential function and the logarithmic functions are related, they're inverses of one another. Now you may remember with exponential functions, the graphs kind of did something like this or something like this. Well, those are one-to-one functions. They're going to pass the horizontal line test, therefore they're going to have inverses, and those inverse functions are called logarithmic functions. Now, think about it. The logarithm is trying to find that exponent. It's trying to find out what that exponent is. I remember years ago in one of my classes I said, what's a one-word definition for logarithm? And I expected somebody to raise their hand and tell me that it was exponent. And some student raised his hand and he said fun. And you're right, he was right, these are fun. And we'll start looking at first rewriting this form, logarithmic form, into exponential form. See, this is called logarithmic form, and this is called exponential form. And they're equivalent, so I want the equivalent exponential form of this. Now, the base of the exponent is the base of the logarithm. So this is base 3. And what's my exponent? My exponent, y, is what well, in this expression, it's what it's equal to. The y is equal to this logarithmic expression. So my exponent here is 2. And what does it equal? It equals, in this case, the x value over here, which is 9. Now you say, oh, I don't know, I might get this backward or something. Here's how I used to tell my students to remember how to do it. Log base b of m equals k. To go from this form into this form, the b comes on over and tries to get up where the k is. The log just drops off. The k is in the way, so all it can do is kind of use its shoulder and nudge it up and over to the side there a little bit. So m becomes, this comes over here, b to the k. So if I bring this 10 over here, nudge the negative 3 out of the way, I get 1 over 1,000 is equal to 10 to the negative 3 power. Now if you go ahead and do the calculations, you'll see that these are true statements. 3 squared is 9, and 10 to the negative 3 is 1/1000. Over here, I have it equal to 0. Bring it over, nudge it out of the way, kind of like it has a little shoulder that it nudges it, and I get 6 to the 0. Well, of course, that's true also, because 6 to, or any number raised to the 0 power is equal to 1, any number other than 0. So look at what I have here. When I have a positive base, whether it's exponential or logarithmic, when I have a positive base not equal to 1, The logarithm is the exponent. This number can be negative. But what you take the logarithm of cannot. You can't take the logarithm of a negative number because that would say some positive number raised to a power is negative. And that's just not going to happen. Positive number raised to a power is positive. Now let's reverse this. Let's go from this form, exponential form, back into logarithmic. Now remember, that's the base of my logarithm. This is going to be a base 2 logarithm. The base 2 logarithm of 32 is going to equal that exponent of 5. Base 10 logarithm here, that's your base, of a 10,000 is going to equal that exponent, which is 4. Base 1/8 logarithm of 64 is going to equal whatever the exponent is, negative 2. Remember, that can't be a negative number. That's not how it's defined. Now this particular log, the base 10 logarithm, we have a base 2 logarithm, a base 1/8 logarithm, a base 10 logarithm. Because it's base 10 and we use a base 10 number system, we call this a common log, or a common logarithm. In fact, we use this one so often that we don't normally write the 10. When if I have log base 10 of 10,000, we write that as just the log of 10,000. It's understood if there's no base written down that it's base 10. That's called a common log. Now I have 3 examples of logarithms here, but none of them are common log. This is base 5, this is base 3, this is base 2. And it says evaluate. How am I going to find the values of these expressions? Well, I'm going to use this conversion form where I change logarithms into exponentials, or logarithm form into exponential form. This is my logarithm. I'm going to call it something. Let's just call it x. And bring it on over, nudge it up. I get 125 equals 5 to the x. Now, 125 is 5 times 5 times 5. So this is 5 to the third power equals 5 to the x. If the bases are the same, the exponents must be equal. X must be 3, so this must be equal to 3. It's kind of like saying, this number to what power is this number? Here, we can do this one in our head. 3 to what power is 81? Well, hopefully you can do it in your head. And let's call it, I don't know, let's just call it x again. So bring it over. 81 equals 3 to the x. 81 is 3 to the fourth. 3 times 3 times 3 times 3. So x is equal to 4. And the log, base 3 of 81 is equal to 4. There's my answer. This one might be a little bit trickier because it has the rational expression, but we'll say it's equal to x again. Bring it on over, nudge it on up, kind of hunker down, shove it up with your shoulder there just a little bit. I have 1 over 64 equals 2 to the x. Well, 1 over 64 is 1 over 2 to the 6. And 1 over 2 to the 6 is 2 to the negative 6. So that means x is equal to negative 6, which means this expression is equal to negative 6. Remember, the logarithmic of an expression can't be negative. You just can't take the logarithm of a negative expression. And we'll look at more examples of this here in just a minute.